Hello my dear students, welcome back to CS Digital Classes. So, now from today onwards, we are going to discussing one more subject, that is Analytical Solid Geometry. Okay, so under Usmania University, B.Sc Mathematics, 6th semester, so we are going to study Analytical Solid Geometry. So now, you can see on screen, so here we have 4 units as we discussed in all the previous subjects. So here you can see in first unit Amma we are going to study sphere. Okay. In second unit we are going to learn about cones. In third unit we are going to study about cylinders, and fourth unit we are going to study about conicoid. Okay. So the study of these entire geometrical shapes is called analytical solid geometry. Okay. So now you can see this is a sphere amma. Okay, looking like a cricket ball kada. So cricket ball, tennis ball, football. So these all circular shape. Second unit is cones amma. So we are going to discussing in second unit regarding cones. And next third unit వచ్చేసి మనకు cylinders. Okay, in third unit we are going to discussing about cylinders, and next in fourth unit we are going to discussing about conicoid. So conicoid means the shape which is existing in this format. Okay, so now you can see conicoid and a cube and a cone and a sphere. So now in this analytical solid geometry, total we are going to discussing about these geometrical shapes. Okay, so now we are moving into first unit of the analytical solid geometry. Unit name is sphere. Here you can see the topics in unit 1. So in this unit 1, the first topic is definitions. Definitions means we are going to discuss all the fundamental definitions of regarding sphere only. After that, next concept is the sphere through 4 given points. Okay. Next, after that, the third concept is equation of a circle. Next, fifth concept is intersection of a sphere and a line. Sixth concept, equation of a tangent plane. And the last concept is angle of intersection of two spheres, radical plane. Okay, these are the total 6 topics we are going to study in first unit. The unit name is called spheres. Okay, so now what is the sphere actually? How it is forming? Okay, so now the locus of any point which remains at a constant distance from a fixed point is called a sphere. Okay, locus of any point which remains at a constant distance from a fixed point, that locus is called a sphere. Here we are calling. Okay, so now diagrammatically I am explaining here. For example, if you take a point here, okay, so another point here, this point I am saying center of the sphere. Okay, from the center of the sphere, okay, if you take the distance, in all the 4 sides okay, so if you take the distance of that point in all the sides, if the distance remains at a constant distance from a fixed point, then if you join all the points then that gives you a spherical shape, or that is called as a sphere. The total collection of the points or locus is called a sphere. Okay, so now the constant distance is called from the fixed point to locus point that constant distance whatever is there, that constant distance here we are calling as this constant distance we are calling as radius. That radius here we can indicate with small r. Okay, radius of the sphere is here we are indicating with small r, and that fixed point is called center of the sphere. You know very well, center of the sphere we can indicate with capital C. Okay, so this is the definition of the sphere. Okay, so the locus of any point which remains at a constant distance from the fixed point. The locus of any point, see, you can take here, at any point you can take, at anywhere amma you can take any point from a fixed point from the center to that point. The distance always remains at a constant value. If you joined all those points amma, that locus gives you the sphere. Okay, so that is the definition. And that distance, that constant distance, whatever we are saying always, that constant distance is the radius of the sphere, and that fixed point from center only we are taking that constant distance na. So that fixed point is called center of the sphere. Okay, so this is called a great circle. This total shape that is called great circle. So this is about total sphere. That is the first concept in unit 1. Now we are going to discussing equation of a sphere. Equation of a sphere, how it will be the general equation of a sphere, and how is the standard equation of a sphere. Now we are going to discussing equation of a sphere. First of all we are going to discuss see, ax square plus ay square plus az square plus 2ux plus 2vy plus 2wz plus small d is equal to 0. సో ఈ అన్ని సెమిస్టర్స్ లో ఏంటంటే మనకు ఒక పర్టికులర్ కాన్సెప్ట్ యొక్క ఈక్వేషన్ ఇంత పెద్దగా రావడం అనేది ఫస్ట్ టైం అన్నమాట. ఓకే, సో జస్ట్ యూ హ్యావ్ టు రిమెంబర్. సో నౌ the product term xy, yz, zx are not there. Okay, so these are the three characters of the standard equation of the sphere. This is the total explanation regarding the equation of a sphere. Now we are going to learn that general equation of a sphere. General equation of a sphere amma. So now x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d is equal to 0. This total equation is called general equation of the sphere. In standard form, in general form, the difference is, so we are taking small a is equal to 1 amma. Okay, in standard form if you substitute small a is equal to 1, then you will get a general equation of the sphere. That is the difference between them. Next, center of the sphere. Okay, in previous slides amma we have studied center of the sphere kada. So then what are the coordinates of the center? And remember carefully, sphere is always three dimensional. Three dimensional ante etlamma manaku x axis, y axis and z axis. So three axes vastayi manaku, x axis, y axis and z axis. Three axes vastayi. So then for each and every point, whatever you are considering, whatever you are taking on sphere, you have to take in three dimensions as x coordinate, y coordinate and z coordinate. Like that also now we have the center coordinates amma. Center we can indicate with capital C. Okay, so center coordinates minus u, minus v, minus w. These are the coordinates of the center. Okay, center of the sphere equation is equal to, here you can see, minus u, minus v, minus w. Okay, next, radius of the sphere. Radius of the sphere small r is equal to u square, v square, w square minus small d. This is the radius of the sphere. You have to remember these two equations. Now third concept, equations of a circle. Equations of a circle. A circle is the intersection of its plane with some sphere through it. Okay, here the main topic is sphere amma, but why we are discussing the circle in the topic of sphere? Okay, so here circle is nothing but, circle is always, just you have to remember throughout the chapter and throughout the subject, circle is the intersection of a plane with some sphere through it. Okay, ikkada circle ante manam etla denote chestamante not only two dimensional shape amma. So in this spheres, circle is always represents with a plane, that plane and intersection with a sphere through it. Okay, so then only it is called a circle. A circle can be represented by two equation representing one sphere and representing other one is a plane. So what is the circle equation in sphere is x square plus y square plus z square plus 2x plus 2vy plus 2wz plus d equal to 0. And the plane equation amma, this is the plane equation, lx plus my plus nz is equal to small p. Okay, the first equation whatever you have, this is the total sphere equation, and the second equation is the plane equation. Okay, so this combined equation taken together represent a circle equation. Okay, so general circle equation is different. So in intermediate level, general circle equation we studied as ax square plus by square plus 2gx plus 2fy plus c is equal to 0. This is the general circle equation. At the time of intermediate level we studied. So now the general circle equation is in sphere in this format. You have to remember. Okay, it is a taken together with plane and sphere. Next point is a circle can also be represented by the equations of any two spheres through it. That means a circle can also be represented by the equations of any two spheres through it. And whatever we discussed first point in this slide, in first point circle is always represented with a plane and a sphere. Now in the second point what they are saying, circle also we can represent as intersection of two spheres, two spheres through it అని చెప్పేసాం. ఫర్ ఎగ్జాంపుల్ ఇట్లా తీసుకున్నారు అనుకోండి ఒక సర్కిల్. సో టూ స్పియర్స్ మీకు ఇట్లా వెళ్తుంటాయి, వన్ మోర్ స్పియర్ అండ్ సెకండ్ మోర్ స్పియర్. దీస్ టూ స్పియర్స్ ఇంటర్సెక్ట్ అయ్యే పాయింట్ మనం ఎక్కడ తీసుకుంటామంటే దట్ ఇంటర్సెక్షన్ పాయింట్ కూడా మనం వీ కెన్ టేక్ ఇట్ యాజ్ ఎ సర్కిల్. నెక్స్ట్ x square plus y square plus z square plus 2fy plus c is equal to 0 comma z is equal to 0 also represents a circle which is in the intersection of cylinder x square plus y square plus z square plus 2fy plus c equal to 0 with the plane z is equal to 0. Okay, so totally we have studied three types of circles in the first unit only. First type is a sphere and a plane. Second type is two spheres at their intersection point if any circle passes through it. And third one cylinder. Actually cylinder అనేది మనకు third unit. So with the help of cylinder equation and with one more plane z is equal to 0, we can also form one more circle. So totally we have three forms of circle in this chapter. Okay, just remember carefully. So this is the total introduction amma. So when you have the clarity and introduction, then only we can understand the concept in the upcoming problems. Okay, please listen carefully. Next concept in this unit is intersection of a sphere and a line. In previous we have discussed about the equation of the circle. Now intersection of a sphere and a line. See, let x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d is equal to 0 be a sphere equation, and x minus alpha by L equal to y minus beta by m equal to z minus gamma by n be the equation of a line. These two equations represents a sphere and line respectively. Now what we are taking intersection of sphere and line. Intersection of sphere and line and we can take in this format. We will get two intersection points. So sphere and line ki point of intersection of sphere and line, you have to remember for each and every point have three coordinates amma. The first coordinate LR1 plus alpha, comma second coordinate m r suffix 1 plus beta, third coordinate n r suffix 1 plus gamma. That is the first intersection point. And second intersection point L r suffix 2 plus alpha, m r suffix 2 plus beta, n r suffix 2 plus gamma. Okay, here what is L, M, N amma? L, M, N are the points we can obtain from the given straight line only. Why? Because the straight line is in this format L, M, N. We can also call them as direction cosines, DCs అని చెప్పేస్తాం. Okay, and alpha, beta, gamma. What is alpha, beta, gamma? They'll give one point in the problem. Sometimes we can take that point as x1 comma y1. Okay, so alpha, beta, gamma we can also take x1 comma y1 comma z1. Okay, so and small r1 and small r2. Small r1 small r2 amma radii of the sphere. ఓకే, సో మనకి ఏంటంటే ఇంటర్సెక్షన్ అని తీసుకుంటామంటే కంపల్సరీ మనకు టూ స్పియర్స్ ఎగ్జిస్ట్ అవుతాయి కదా. సో r1 ఈస్ ద రేడియస్ ఆఫ్ ద ఫస్ట్ స్పియర్ అండ్ r2 ఈస్ ద రేడియస్ ఆఫ్ ద సెకండ్ స్పియర్. సింప్లీ మనం ఏమని చెప్తామంటే రాడీ అని చెప్పేస్తాం, రాడీ ఆఫ్ ద స్పియర్ అని చెప్పేస్తాం. ఓకే, సో దిస్ ఈస్ ద యూ హ్యావ్ టు రిమెంబర్ దిస్ ఈక్వేషన్ అమ్మా, ఇంటర్సెక్షన్ పాయింట్ ఆఫ్ స్పియర్ అండ్ ఏ లైన్. ఓకే, So based on this formula also we have problems in stages. Next concept is equation of a tangent. Equation of a tangent plane. Equation of a tangent plane. So if you take a sphere like this, equation of a tangent plane like this we can take equation of a tangent plane. Okay, so plane. Now the equation of a tangent plane to the given sphere at the given point alpha, beta, gamma. See, if you take a random point in this unit to random go, we can take that point as alpha, beta, gamma instead of x1, y1, z1. Okay, just remember that thing. Now to say that the tangent equation or tangent line or tangent plane, we need one point of contact. That point of contact is alpha, beta, gamma. Point of contact means this point. Okay, sphere and plane. So these two sphere and plane will touch each other at one point. That point here we are taking alpha, beta, gamma. So now what is the tangent plane equation for the sphere is alpha plus u into x plus beta plus v into y plus gamma plus w plus into z plus u alpha plus v beta plus w gamma plus d is equal to 0. So you have to remember there is no other option. Why? Because the standard form of the sphere only is very lengthy but very easy to remember. So in that format, tangent plane equation is linear equation of first degree, not a second degree. That's why there is no square terms. Just linear equation you have to remember alpha plus u into x plus beta plus v into y and gamma plus w into z. U alpha plus v beta plus w gamma plus d is equal to 0. That is the tangent plane equation. Very important. Okay. If a plane touches a sphere, then the length of the perpendicular distance from its center to the plane is equal to its radius. Okay, just now we discussed about that tangent plane equation kada. So sometimes they will ask in the examination one plane is there, so that plane is touching the sphere at this point. So now to say that plane is the tangent plane to that sphere, we have to prove the radius of the sphere is equal to perpendicular distance from the center of the sphere to that plane. Okay, so in school, in intermediate level also we discussed the same thing to say that the common tangent, so radius of the circle is equal to perpendicular distance of that from the center of the circle to that line and చెప్పుకుంటాం. Same concept here we are going to discussing. Okay, so the length of the perpendicular distance from its center means center of the sphere to plane equal to its radius of the sphere. Then only that plane is called tangent plane or touches. The condition for the orthogonality of two spheres is the condition for the orthogonality of two spheres. So what is the orthogonality? If two spheres are perpendicular to each other, are making 90 degrees. Okay, so how can we see the angle between the spheres? So see, to calculate the angle between the spheres we have to take the tangents. For example, I'll write like this: two spheres. Take two spheres in this format, one sphere and one sphere. So for this sphere, one tangent line I am taking like this, and for the second sphere another tangent line I am taking like this. These two tangent planes are intersecting at this point. Okay, so at this point that angle is 90 degrees. At that point angle is 90 degrees. Then these two spheres. Okay, so sphere S1 you can take, this sphere S2 you can take. S1 is equal to 0 and S2 is equal to 0. These two spheres are said to be orthogonal spheres, are orthogonal to each other. So then what is the condition to say that two spheres are orthogonal? The condition is 2u1 u2 plus 2v1 v2 plus 2w1 w2 plus is equal to d1 plus d2. That means here I am writing 2u1 u2 plus 2v1 v2 plus 2w1 w2 is equal to d1 plus d2. This is the condition. Okay, if you take 2 common, you can say u1 u2 plus v1 v2 plus w1 w2 equal to d1 d2. Then what is that small d1? Small d1 d1 is the perpendicular distance from the center of the first sphere to tangent line. This is the d1. And what is the d2? perpendicular distance from the center of the second sphere to its tangent. Okay, so we have to calculate in that format. So if that value is equal, then we can say both the spheres are perpendicular to each other or orthogonal spheres. Now one of the important concept from this unit is radical plane. Radical plane, the radical plane of two spheres. Okay, so what is the radical plane? First of all, radical plane is nothing but same as I explained previously. So if you take two spheres, okay, the between line, two spheres between, if you draw any line, okay, or any plane, that plane is called radical plane. That's it. That's it. The definition of the radical plane ante. So that is not a exact definition. If you take two spheres, so two spheres between, if any line passes or any plane passes, that plane is called radical plane. But it has to satisfy the condition is S1 minus S2 is equal to 0. That radical plane of two spheres, S1, first sphere if you take S1 is equal to 0 and second sphere S2 is equal to 0, then the radical plane of the two spheres we can say, we can give the equation as S1 minus S2 is equal to 0. Anyhow, you know very well, plane is nothing but first degree only. So if you apply this formula, S1 minus S2 is equal to 0, all x square plus y square plus z square term will get cancelled, amma. X square plus y square plus z square term will get cancelled. Then the remaining values, for the remaining values, if you take 2x, 2y, 2z common, the remaining values, if you simplify, you will get an equation in this format. Okay, 2x u1 minus u2 plus 2y v1 minus v2 plus 2z w1 plus w2 plus d1 minus d2 is equal to 0. This total equation gives you the radical plane. Okay, so simply remember S1 minus S2 is equal to 0. Even if you apply this condition, you will get this process only. Okay, so now next, last but not least, so coaxial system. Coaxial system, one of the very important concept in this unit for the especially LAQ long answer questions. A system of any two spheres have the same radical plane. A system of two spheres, okay, a system of two spheres, if they have the same radical plane, that system is called coaxial system. Okay, so next, the equation of the coaxial system is given by, equation of the coaxial system is given by S1 plus k into S1 minus S2 is equal to 0, where k is any parameter, where k is any constant value. So this equation gives you that S1 minus S2 equal to 0, gives you the radical plane. That radical plane, if you multiply with k and add with the first sphere, then you will get that coaxial system equation. Okay, so now we have discussed about all the concepts of the first unit, amma. So first we have discussed about the topics in unit 1, and second, we discussed the definition of the sphere, and next we discussed that equation of the sphere and standard equation and general equation. Next we discussed equation of a circle. Three types of equation will be there. Okay, just remember. And next, intersection point also we discussed, Rama. Next, tangent plane and what is the condition for the tangent plane. Okay, and orthogonal spheres also we discussed what is the condition also, and radical plane and coaxial system. These are the very important topic in this unit. So from next video we are going to start problems based on all these concepts. Okay, so make a perfect practice, prepare very well. Okay, thank you.